Good afternoon, Algebra 2 students. It's time for us to do Lesson 11.5, the sum and difference of cosine and sine. This first slide here is going to be something that is useful. I'd like to recommend that before you go any further in this video that you pause this and write this down on a note card. This is going to be something that will be useful on your homework, on your tests, and to understand the concepts that are given. These formulas will help us navigate through the rest of the lesson. So pause the video, put them down on a note card, and then start me up again. As I look at this, it says find the exact value of the cosine of 15. We put together a trig chart just a little while ago, and on that trig chart it had exact values. Some of those exact values you'd have for the angles would be for 0, 30, 45, 60, and 90. It went on and on and on, and you should have a whole trig chart available for you now. On that trig chart, you had a sine column and a cosine column. We learned from a 30, 60, 90 triangle and a 45, 45, 90 triangle a lot of these various values. So if we did that, we have 1, 1, square root 2, and 1, square root 3, 2. We learned that the sine of 0 was 0, and the cosine of 0 was 1. With 30, we had the sine of 30 being 1/2. The cosine of 30 was square root 3 over 2. 45, it was square root 2 over 2 and square root 2 over 2. The sine of 60 was square root 3 over 2, and the cosine of 60 is 1/2. The sine of 90 is 1, and the cosine of 90 is 0. I get all these from my unit triangles over here. That chart had many more things on it, but these are the ones that would be useful. These are exact values. When you have like the square root 2 over 2. Square root 2 over 2 is exact. And if I were to put that in my calculator, I'm going to get an approximate value. Like if you tried on your calculator right now, most calculators, if you put the sine of 45 degrees, it would say that it's approximately 0.7071. Again, that's an approximate value where this value here is exact. And if you tried on your calculator to do the square root of 2 and then divide it by 2, you would get 0.7071. So this question here asks the exact value. I've got a calculator sitting right here, and so I'm going to take my calculator and I'm going to push the cosine of 15 degrees. And when I press cosine of 15 degrees, I get approximately 0.95 or 9659. That's an approximate value. Now remember, this homework assignment asks for an exact value. So I'm going to say that what we want to do is we want to refer back to the page before us or to the note card that I hope that you have. And what we're going to use is we're going to be able to use any value that we have on our chart here our trig chart, in order to be able to plug them in to these formulas. So if we look at the second formula that we have right there, hopefully you have it on a note card. If we look at that second formula, I think that's going to apply here. So what I'm going to do is I'm going to start on this slide. I'm going to write down that formula. It says the cosine of x minus y equals the cosine of x times the cosine of y plus the sine of x times the sine of y. And you might say, okay, Mr. Wilson, that's fine, but how does that help me get to the exact value? Well, what I'm going to do is I'm going to focus on this particular x minus y value. And I'm going to try and see if I can't come up with the number 15 from these values here. I hope if you look at this kind of quickly, you can see that right here and right here, I have two values that are going to help me get to 15. Because 45 minus 30 is 15. Does that make sense? So the cosine of 45 minus 30 is equivalent to the cosine of 15 degrees. Does that make sense? I hope so. But one of the things that I want to begin playing in is that 45 is x. See here, x, 45. And 30 is my y value. So any place that I have x, I'm going to put 45. So I'm going to have cosine of 45 times the cosine of 30 plus sine of 45 times the sine of 30. Now it comes down to just performing simple math, which I think we all can do. So the cosine of 45 minus 30 is equal to the cosine of 45, which my chart right over here says is the square root of 2 over 2. The cosine of 30 is the square root of 3 over 2. The sine of 45 is the square root of 2 over 2. And the sine of 30 is 1/2. Hopefully you can see where I got all these values from. Let me just highlight one for you right now. The last one we did was the sine of 30. You can see here the sine of 30 is 1/2, and so that's why I put that in that location. Now, let's simplify this. The simplification step is going to say that the cosine of 15 degrees is equal to the square root of 6 over 4 plus the square root of 2 over 4. You'll notice that I have common denominators, so I can smush those two values together, and I'd have the square root of 6 plus the square root of 2 over 4. That is how we use the formulas from the slide previous. Again, we'll move on, and I'll give you another example. This one says the sine of 105. One of the things that will really help you out is if you have that trig chart sitting in front of you that I provided with you with last chapter. I said in my notes to make sure that you hung on to that because it would be important for Algebra 2 for the rest of the year and for calculus and pre-calculus next year. So make sure that you hang on to that trig chart. Also, if you can have that note card in front of you, that would be wonderful. So I'm going to take a look at the sine of 105 and see if from the values that I've listed, anything on your trig chart, if I can come up with 105. I think personally, as I look, the best option, now there's more than one way to get to 105. You can subtract a couple of values, but the one that I find to be most beneficial in this case is to say that it's 60 plus 45. Does that make sense? 60 plus 45 is 105. I hope it does to you. So now I'm going to take a look at that note card that I've put together, and I'm going to say what formula will work best for this problem. I think it's going to be this one. The one that says the sine of x plus y equals the sine of x times the cosine of y plus cosine of x times the sine of y. That ought to work. So now what we're going to do is we're going to begin substituting in values. Our x value is going to be 60. Our y value is going to be 45. So we're going to have the sine of 60, because remember x is 60, times the cosine of 45. Remember y is 45, plus the cosine of 60 times the sine of 45. Do you have that trig chart in front of you? That will become very, very important for our next step. In our next step, we're going to take a look and we're going to say here that we're going to begin putting in the values that we have. So on a trig chart, we find that the sine of 60, if you look it up, you're going to find that the sine of 60 is the square root of 3 over 2. Now you're going to notice that as you do these exact values, you're going to have a lot of answers that are very, very similar. That's okay. If you say, well, I got two answers that are just about the same, that's fine. A lot of these are going to be very close to the same. If you look up on the chart the cosine of 45, you should get the square root of 2 over 2. If you look up the cosine of 60 on your trig chart, you should get 1/2. And if you look up this sine of the square root of 45, you should get the square root of 2 over 2. Now let's begin to simplify. The next step, what we see, is that 60 plus 45 is 105. The square root of 3 times the square root of 2 is the square root of 6, and that's over 4. And 1 times the square root of 2 is the square root of 2, and that's over 4. You'll notice that I have common denominators. So the square root of 105, we can smush them together and get the square root of 6 plus the square root of 2 over 4. You will notice that this is an exact answer, not an approximation. There have been many times when teaching over the years that I've had students that they get to this point and we go through the class and then it's time for the homework, and I get their homework back the next day and it says specifically in instructions give exact answers, and they give me an approximation. Anybody can go onto their calculator and type in the sine of 105. As a matter of fact, if I did that, my calculator would give me sine of 105 equals 0.9659. You know what I'm going to do if you put that? I'm going to say, because any second grader can push buttons on a calculator. But the tricky thing is to be able to do this work, to work through the steps to get an exact answer. That's what we're looking for. All right. Next question says, find if we have the sine of A as 3 over 5, find the cosine of A, the tangent of 2A, the sine of 2A, and the cosine of 2A. The first thing that I'm going to do in doing a question like this is a little bit different than the last ones, kind of kicking it up a little bit of a notch, is I'm going to draw a triangle. All right? And in this triangle, what we're going to end up doing is we're going to give a value of A to one of the angles. It doesn't matter which acute angle it is. You just have to select one. So one of the things that we're going to do is we're going to say the opposite side of A is 3. And the hypotenuse, of this problem is 5. Then it says find cosine of A. Well, what we know we've already learned this, is that cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And if we're talking about A, the opposite side is 3. The hypotenuse is 5. And the adjacent is what I don't know. Can you think of a way that we can calculate the third side of a right triangle? Yes. Since the beginning of your high school math, you've been learning about Pythagorean's theorem. A squared plus B squared equals C squared. So if we call A, we don't have to. We could call it B the variable too. But I'm using A for adjacent. And B squared, the other leg of this right triangle, is 3. 3 squared is 9. And the hypotenuse squared would be 5 times 5, which is 25. A little bit of subtracting 9 from both sides, and we get A squared equals 16. A thus equals plus or minus 4. Can't be a negative value. So we're going to go with the adjacent side is equal to 4. Now, I believe that we can locate and figure out what the cosine of A is. The adjacent side is 4. The hypotenuse is 5. So therefore, the exact value of the cosine of A is 4 over 5. I hope that makes sense. What about tangent? What is tangent's reciprocal value? If we put the rational value, not reciprocal, excuse me, rational value, it's opposite over adjacent. Now, if you look at this, you could see that we know the opposite value. The opposite value is 3. And the adjacent value is 4. So that helps us find the tangent of A and the cosine of A. The next question it asks for is the sine of 2A. Now, if you're doing this lesson, one of the things that you're going to want to do is you're going to want to make sure that you have that card in front of you. You remember the card that we made just a little while ago? It looks something like this. As a matter of fact, if I were to look down, I see a bunch of formulas called the double angle identities. The double angle identities are found right here. These are double angle identities. One of these is going to be handy for our sine 2 alpha, and that's this one right here. All the rest could be used for cosine of 2a. You got to pick which one is your favorite. And honestly, it doesn't matter which one you choose. Sometimes one will be more handier than the other. So the first thing we're asked here today is the sine of 2 alpha. We just learned on our last thing that if we're looking for the sine of 2, now I don't remember because I was just looking at it. If on that card, if it said sine of 2x, it might have said sine of 2a. I don't remember. But anyways, the formula reads that it's 2 times the sine of x times the cosine of x. If your card has a instead of an x, that doesn't make too much of a difference. But in this particular case, we are using a's. So we're going to say that the sine of 2 times 2a, or double the angle, is the same as double the sine of that angle times the cosine of that angle. And it just so happens that we already have the sine of a up in the instructions. Let me highlight it for you. It's that right here. the sine of A is 3 over 5. So down there, right there, I'm going to put, well, still in highlighter mode. I'm going to put in 3 over 5. And the cosine of A, says right there, is 4 over 5. Now if I multiply the numerators, I'm going to get 24. 2 times 3 is 6. 6 times 4 is 24. And then the denominators is 25. So my solution would be 24 over 25. Does that make sense? Now the last question on this slide says, what about the cosine of 2 alpha? Remember, I said you can use any one of those problems those formulas that you want. So the one I chose was the one that reads cosine of 2a equals cosine squared of a minus sine squared of a. Again, every single one of those formulas would work. But the cosine of 2a equals cosine of a squared. Well, the cosine of a is 4 over 5, but then we're going to square it. Minus the sine of a, and the sine of a is 3 over 5, but we're going to square it. So, the cosine of 2a equals 4 squared 16, 5 squared is 25, minus 3 squared is 9, 5 squared is 25. So if I do 16 minus 9, I'm going to get the cosine of 2a equals 7 over 25. So my solution for the last question there is 7 over 25. How are we doing? I hope you're getting this so far. Let's move forward. So here it says, find the sine of A plus the sine of B. Again, I'm going to refer to that little card that I have in front of me in order to find the formula that I need. And the formula that I'm going to use is the sine of A plus B, or I know the card says X and Y. I'm just going to change it to A and B because this particular question uses A and B, so I'm just going to replace every X with an A and every Y with a B. So the sine of A plus B equals the sine of A times the cosine of B plus the cosine of A times the sine of B. So what that means is I need the sine of A and the cosine of A. And I also need sine of B and the cosine of B. So if I were to look at this first one, 8 and 3. 8 is excuse me. This is opposite. This is hypotenuse. And we need to do the adjacent side. So if we plug in Pythagorean's theorem, that'll help us a lot to get that last side. A squared plus B squared equals C squared. This is going to be 64. This is going to be 9. And we're looking for A squared. 64 minus 9 is 55. So A squared equals 55, making our adjacent side the square root of 55. Let's do the same thing on this particular triangle. A squared plus B squared equals C squared. A squared plus 25 equals 81. I can subtract 25 from both sides. When I do that, I'll get A squared equals 56. So A equals the square root of 56. you know that we can simplify that, I hope. So when we do, if we take 56 and divide by 4, we'll get 14. So it becomes 2 root 14. So the opposite side is 2 root 14. Now we should be able to figure out my sines and cosines. The sine of A is the opposite side over the hypotenuse. The opposite side is 3. The hypotenuse is 8. For the cosine, the adjacent side is the square root of 55, and the hypotenuse is 8. I now have the sine of A and the cosine of A. I'm going to do the same thing with B. The sine of B is 2 root 14 over 9. The cosine of B is 5 over 9. Now I can plug those back in to find the sine of A plus B. We've already calculated the sine of A. We know that the sine of A is 3 over 8. The cosine of B is 5 over 9. The cosine of A is the square root of 55 over 8. And the sine of B is 2 square root 14 over 9. That's a lot of square roots in that last one. I didn't honestly plan it that way, but that's how it worked out. So, as we move forward, we could say 3 times 5 is 15. 8 times 9 is 72. On the other one, we have 55 times 14 gives me 770. So what I end up with is 2 square roots of 770 over 72. As you look at that, you can probably see that what's going to happen is actually 770. Just thinking about this. 770, 10 and 77 is 7, 11, 2, and 5. And those are all prime numbers. You can't reduce the square root of 770. Oh my goodness. I can't believe that. We can't reduce that at all. That's kind of a pain in the neck. So our answer is going to be the sine of A plus B equals 15 plus 2 root 770 over 72. That's my exact answer. Kind of nasty, but we got it. Hope you guys are doing good. Let's move on to another problem. This is a trig identity. You remember trig identities from the last 2 days. We've been working on trig identities. This particular one, we want it to look like the other side. So we're going to take the formula that we have, and we're going to try and put it in right here. I know that what we've done in the past is we've kind of worked with the more difficult side, but what makes this more difficult is that the double angle identity. And honestly, if you look at the card that you have in front of you right now, I think you're going to find out that this identity is already on that card. The point is that we want to prove that this is actually the second identity on that card, and we want to prove that the left-hand side equals the right-hand side. So what we want to do is we want to take the first formula that we have. The first formula that I have is cosine squared A minus sine squared A equals cosine 2. Whoops. Sorry, I don't know why my computer does that once in a while. 2A. So as we look at this, we want this side to be manipulated until it reaches the other side. And I sit here and I go, what am I going to do? And remember the keys to solving trig identities. Key number 1, turn everything into terms of sine and cosine. I already got that. Key number 2 is look for Pythagorean's identity any place you can. Well, I know that Pythagorean's identity says sine squared plus cosine squared equals 1. Remember that? So if I were to look here, I've got cosine squared here and here. So I'd like this to equal cosine squared. So I'm going to say cosine squared equals 1 minus sine squared. So what I can do is I can take this, well, let me get a yellow, and I can substitute it in there. And when I do that, I'm going to get 1 minus sine squared alpha. I just substituted that in for that. Minus sine squared alpha, or A. Now you see here I got 1 negative sine squared, and I have another negative sine squared. Well, if I had one apple and another apple, I put them together, I'd have 2 apples. The same thing applies here, and I'd have 1 minus 2 sine squared alphas. Now if you look, you pay attention, that's what I was looking for. I've proven my identity. Life is good. These can be tricky sometimes, so if you got a question, give me a call, send me an email, let me know, and I'll be happy to help you walk through one. This is another trig identity, and this one I'm going to use the cosine angle identity that we found on our note card with A plus B. A plus B. So the A plus B formula that you find on that note card is the cosine of A plus B equals cosine A, cosine B, minus sine A times sine B. Okay? So now, in this case, you'll see A is 180. I know the cosine of 180 is negative 1. And I know that the sine of 180 is equal to 0. The sine of 180 is equal to 0, and the cosine of 180 is equal to negative 1. You're saying, Mr. Wilson, how did you know that? Do you want to know how I knew that? What I did was I looked on the trig chart that I said to have in front of you. That's what's really going to help. So anytime we see A, we're going to substitute that with 180. So what we got is the cosine of 180 plus x equals the cosine of 180 times the cosine of x minus the sine of 180 times the sine of x. So the cosine of 180 is negative 1. So it'd be negative 1 times the cosine of x minus the sine of 180, which is 0, times the sine of x. Well, what's 0 times anything? We know that that's 0. It's gone from the equation. So what we're left with is the cosine of 180 plus x is equal to negative cosine of x. That's exactly what we wanted to begin with. We've proved it. Life is good. Okay? Here it says find the exact value of the expression. This is one I don't think I'm going to challenge you with on your homework, but I'd still kind of like to go over it with you. If I were to look at this, and I were to say, man, this is cosine of A times the cosine of B minus the sine of A times the sine of B. Look on your note card. See if you have anything that's very, very similar to what you see. I bet you if you look on your note card, you're going to notice that that's equivalent to the cosine. Excuse me, again, don't know, you guys know from class that happens sometimes. The cosine of A plus B. The cosine of A plus B that's what that is. So if I were to take A, which we decided was 20, and B, which we decided was 40, that would be the cosine of 20 plus 40. Well, what is 20 plus 40? It's 60. Whoa, look at your trig chart. Do you find the number 60 on your trig chart? Absolutely you do. And when you do, you find that the exact value of 60 is 1/2. It was an awesome application of the sum of cosine angle identity. There's your homework, 11.5, numbers page 510 to 509 to 510. That was what your homework was supposed to be. However, with this COVID year, I'm going to trim it down a little bit. And so what we're going to do for 11.5 is we're going to change that to, let me look at my notes here, 1 to 7 and 15 to 17. Got any questions? Let me know. And I hope you have a great day. Do your best on these double angle identities. See you later.